Good morning, everyone, and welcome. Hi, everyone. Good morning and welcome. Can I have 1 or 2 minutes to all other participation of joining us? So we will wait for another 2 minutes. Thank you all the participation. So we start the section. Good morning, everyone, and welcome. On behalf of Milton Roy Mixing and Industrial Brand Business, thank you for joining our webinar, Master Industrial Mixing Optimized Process Performance with Milton Roy. We appreciate your participation and hope today's section is insightful and valuable. During the webinar, our experts will share practical insights into our industrial mixing, mixer selections, process optimization, and engineer-to-order solutions. If you have any questions, please post them in the chat or QA sections. We will address them at the end of the section. Now, it's a pleasure to introduce Mr. Rishab, Assistant Manager of Application Engineer, Milton Roy, India Region. Over to you, Rishab.
Thank you, Vanaganji. Thank you so much for the wonderful introduction. So right now, thank you all of the participants to join for this Master Industrial Mixing webinar. So it's really a pleasure and good morning to everyone. Thank you for joining this webinar. I am Rishab Shukla from Application Engineering Team for India region from Milton Roy in the Solrat. And along with me is Kuldeep from Design Engineering. So over the next hour, we will be covering the industrial mixing fundamentals, selections, principles, and key applications across industries, and the capabilities of Milton Roy Mixing. So you can see our purpose. Everything we do is definitely guided by one simple purpose: making life better. That applies to all the employees, customers, shareholders, and the environment. So it drives our commitment towards innovation, safety, sustainability, and long-term customer success. So this is about our purpose. We have environmental goals. So as a part of IR family, sustainability is one of the major priority which we take into consideration. We focus on reducing environmental impact through efficient technologies. Then we have responsible operations and continuous improvement in the sustainability initiatives. So this is about our environmental objectives and goals, which we have up to from 2030 and 2050. So we try to achieve them, taking different initiatives for waste reduction, water conservation, and net zero greenhouse gas. Yeah. So this is about our expertise, wherein Ingersoll Rand is specializing in different mission, critical flow and application involving fluids, liquids, gases, solids. So we are our technology is definitely supporting pumping, transfer, storage, dosing, treatment, and as well as mixing. So this is about our primary solutions which we are offering. For air and gas, we have compressors, blowers, vacuum pumps. For liquids, we have PD pumps, mixers, medical devices. Of solids, we have blowers and biopharma single-use technology. mixtures, we have PD pumps and mixtures. So these are different solutions and portfolio synergies which we offer. Yeah. So next slide is about our technology leadership, wherein we have marketed uh, in different kind of equipments. We have compressors, blowers, vacuums, pumps and systems, and single-use technology. So you can see we have a strong market position in technology innovations, global expertise, and we have a broad portfolio of products. So based on this, we are having a huge amount of equipments. You can see the active patents we are having around 88% with sustainability benefits, more than 2,300 engineers, expertise in hardware, software, and controls. So this is about our product portfolio and technology leaderships. So as per this slide, we have Ingersoll Rand divided into two verticals: industrial technology and services, and precision science and technology. So we have a huge amount of brands associated with Ingersoll Rand. So as you can see, we are in the second slot for precision and science technologies. We are included in this vertical, along with other brands, well-known brands for CPEX, Thomas, ARO, Rosatron, Haskell. Then we have LMI, Milton Roy Pumps, Milton Roy Mixing, William Pumps, YZ. So we have a huge. You can see the different brands which we own and which we offer to the customers. So this is about our which we are serving to the chemical, wastewater, and oil and gas, along with mining and other different sectors. Next. So this is about our evolution. For around more than 65 years, we have been evolving ourselves from 1871 till date. We have been evolving through different impellers and mixing technology. We have patented them. We have different Robin mixers from HPM design. Sorry, we have side enter mixer design. We have HM range of mixers. So you see 1956 to 71, 2004, 1895, 1959, and 1998. So wherein we evolved ourselves in the market, and with respect to Robin Industries, we have HM top entry mixer range, side entry mixer range for top entry for wastewater, and side entry for oil and gas industries. So basically, this is about our journey for the past 65 years, how we have been evolving through this journey. So this is our presence around the world, wherein we definitely we are operating from Chennai, involving quotation and project execution team along with engineering and manufacturing. We have sales office at Dubai, along with manufacturing at Shanghai, sales office at Singapore, and in Africa we have in Johannesburg. Across the different continents, in North America we have in USA. Then you go to Europe, we have the execution manufacturing unit in Pont-Saint-Pierre, France, where we have whole project execution and manufacturing team. We have a competence center in Avon, France, where we are having R&D team along with applications, engineering, and design for all the types of mixers, wherein we have the lab and technical support available for all the different regions around the world. So this is about our presence around the globe. We are serving to all the customers based on the this particular locations. So from India, we are supporting Southeast Asia, Middle East, India, as well as Europe. So this is about our presence, and we are providing all the quality products from here, as well as from the manufacturing units around the world. So next. So Yeah. So now I will hand over my presentation to Kuldeep, who will be taking ahead regarding the Milton Roy mixing from here. Kuldeep. Yeah.
Hi, good morning, everyone. My name is Kuldeep. I'm working in Milton Roy from past 6 years in engineering department. So yeah, so Rishab just explained about the brand, Ingersoll brand, what all we do, what is the brand Milton Roy Mixing. So we'll just from here onwards, like we'll carry about the mixing process, like what are mixers, why they are required, what are different types of mixers, what all processes will require mixers. So we'll cover from basic, like what is mixer, how it is selected. So all those things will be covering in next few slides. And so here, so mixer like can be, so here we are just representing that it can be a very small mixer installed in a 100-liter tank to a very big mixers installed in 10,000 meter cube, or even like for crude oil storage, it could be higher, like 200,000 meter cube of tanks. So the range is very vast. Like it could be a very small mixer to very big mixer. And at Milton Roy, we fabricate everything starting from small mixer to big mixer. So here in the image, if you see, it is one of our mixer installed in alumina application. This is precipitated tank for alumina application. So it is around 43 meter long tank with multiple stages of impellers inside the tank. And coming to the mixing knowledge, so mixer is like not for designing a proper mixer, we don't only need the knowledge of the mixer, we need the knowledge of the process as well. So that's why in coming slides I'll be explaining, like we do not manufacture mixers for all the application. We designs and provide our mixers to very specific application where we have good process knowledge as well. So we have process engineer from different specialties where all we are providing the mixers. So process engineering knowledge is very important to select the right mixer for the process. And then we need other kind of knowledge like designing knowledge regarding designing, then rotating equipment, knowledge of the components coming inside the mixer, like motors, gearboxes, shaft, impeller, mechanical design of these components. We need to have the knowledge. And one more thing, like we have a specialized team for CFD simulation. That is also very important, so that we provide the right mixer for right operation, for right process. So we have a team dedicated for CFD simulation. In coming slides, I'll be explaining why CFD simulation is important and what we do in CFD simulation and how it could help in selecting the right mixer and saving the operating expenses if the right mixer is selected. Then one more specialty what we have is we do laboratory testing. So for laboratory testing, like suppose we want to design a mixer for a new process. So in place of directly designing the mixer, going to the bigger tank, we do scale down model. We do a small tank in our lab, and we request the customer, or we arrange the right slurry that equivalent to the slurry the end customer will be using. And we do scale down model. In that we do a lot of testing, like what is the optimum power, what is the optimum flow required for that process. And once it is established, we provide our mixer for bigger tanks, so that the process, we already know how the mixer will be behaving with the process, and so that the right mixer will be selected without overpowering it, or without giving the optimum flow, not underflow or overflow. And then obviously, like mechanical engineer knowledge is required for designing the components coming in the mixture. Like we have to calculate the forces, hydraulic forces acting, the mechanical forces acting on the shaft, impeller, and it has to be mechanically designed in a right way, so that it will take all the static and dynamic loads acting when the mixer is rotating inside the slurry. So we have experts from all the different fields that is required for selection and designing and manufacturing of a right mixer. Yeah. So now we'll start about mixer, like what is mixer, why mixing is required, what are the different types of mixers, where all it has to be used. Yeah. So this is like what is mixing. So this slide covers the basic definition of mixing. What is mixing? So mixing, like if you want to define it, this is the process. Like mixing is a process to reduce the inhomogeneity in a process. Like suppose if a process is there, if you expect any inhomogeneity, it could be either temperature difference or density difference or phase difference. So if you want to reduce inhomogeneity, you need mixing so that the process or the solution becomes homogeneous, or what all fluids inside the tank, it becomes homogeneous. So that is how we define the mixing. It is defined as reduction of inhomogeneity to achieve the desired process result. Okay, and inhomogeneity, as I explained, could be of different type. Either could be density difference, temperature difference, phase difference. This is what mixing is. And some of the examples of mixing are shown here. So like suppose you are mixing water with the sugar syrup. So once you mix it, like because of the density different, sugar syrup will be settled at the bottom and water will be at the top, as you can see in image 3. And once you mix it, like in this case, like suppose with a spoon you mix it, it will become a homogeneous solution. Like sugar syrup will be blended in water. So this is an example of blending. Blending is like when we are mixing two liquids that will not mix on its own due to density difference or some other difference. So this is an example of blending. And other example like what we are using in our day-to-day life are dissolution, where we are mixing salt in water. So it's dissolution because the solution will be formed. It's not like the salt will remain suspended in the water. So it's mixing with the water until certain concentration. So it is an example of dissolution. Then we have solid suspension. Like suppose if you are trying to suspend sand particles in water, so it will not mix, but maybe you want to keep it agitated. So that's not mixing, that is agitation. You want to keep it agitated. You don't want the particles, in this case sand particles, to settle at the tank bottom. So it will be required in applications where you have to pump slurry from one tank to another tank. So you cannot let the solid particles settle at the bottom of the tank. Otherwise, the pumping will not happen properly. So in that kind of application, solid suspension will be using. It will not be mixing, but the particles will be remaining suspended so that it can be pumped to the other processes. Another example is heat transfer. So in this case, like suppose you have only one fluid, like if you have only water, but there is a heating taking place. So heating, once you heat it, so heat will be concentrated, like based on the position of heating coil. It will be concentrated, like heat will be more around the heating coil and it will be reducing. So once you provide mixing, due to the velocity increase inside the tank, the temperature can be maintained uniform. So that is another example of mixing. And gas dispersion, like if you are to introduce some gas like hydrogen or oxygen inside a fluid, then mixing can be done. Like you need to give a gas disperser, and over that, like with mixing, the dispersion can be more effective. Yeah. So now we understood what is mixing. So it's the process of reducing inhomogeneity. Inhomogeneity could be of different things. So what is the purpose? Like why do we mix? Why we want to reduce the inhomogeneity? So this slides represent that with examples. Like suppose we want to mix ethanol with gasoline. Like nowadays we are getting petrol mixed with the ethanol. So we want to mix it. Due to this density difference, it will not mix automatically. Like if you put those two liquids inside the tank, it will not mix on its own. So we need to give mixing. So for that, mixing will be required. For solid suspension, as I said, like suppose you are having iron ore and you want to pump from one tank to another tank. So if you don't mix it, iron ore will be settled at the tank bottom and water at the top. You will not be able to pump from one tank to another tank. So in that case, you need to mix it. So that is coming under solid suspension. It's not mixing, but the particles are getting suspended, like how it is shown in the last image here at the bottom. Sorry. Yeah. And then that could be like dissolution. So in this case, like the solid particles are mixing inside the fluid to make a solution. For example, like if you are mixing sugar with water, or industrial example is like when you are mixing polyelectrolyte powder with water. So that is used in wastewater treatment application. So in that case, like one solution will be prepared and that solution will remain as a solution. It's not like if you remove mixing the solution, the particles, the phases will get separated, not like that. So once the solution is prepared, it will remain a solution. So it's coming under dissolution. Then it could be like liquid to liquid dispersion. So it's like different from blending, because one liquid disperse into another liquid, like how we are making oil in water. So that is like emulsification or dispersion. Then we have gas dispersion, like as I explained, oxidation of hydro or putting hydrogenation reactors. And then we could have heat transfer, so where you like without mixing, the heat will be concentrated at one place, and you want the heating or the temperature to be uniform throughout the tank. So in that case, mixers are useful for reducing the inhomogeneity in temperature. And one of the example is in sulfur melter tanks, we are giving our agitators. So solid sulfur is melted into that tank to make sulfuric acid in further processes. So in that case, like heating coils will be there and solid sulfur will be fed, and then we have to the mixer will help in proper heat transfer, so that the end process you'll get the liquid sulfuric. Yeah, and another thing is like for chemical reaction. So for increasing the speed of chemical reaction, or for making making it more efficient, like we want to make sure that the particles you are putting for chemical reaction are properly utilized. For that, mixing can help. It increases the surface contact surface area, so that the reaction happens properly. So one of the example is phosphate rock in sulfuric acid. And so this is used in sulfuric acid reactor, where we put phosphate rock with the sulfuric acid along with water. So the outcome will be phosphoric acid used for making for different type of fertilizers. This one, like what is the purpose? Like where like few example where the mixers are used in industries and what it is doing. So in this slide we are covering that. Yeah. So for this slide, like suppose, like, okay, now you understood what is mixing, whether mixing is required for your process or not, you can make it out. So next thing is, like, suppose you want a mixer and you want to approach one OEM like Milton Roy Mixing, like we want a mixer. So what all data is required for selecting the right mixer? So that is covered in this slide. So we have this sheet, data collection sheet, where we send it to our customer and ask them to fill it. So based on that, we'll be able to select the right mixer. So here we'll just quickly go through like what all things will be required for selecting the right mixer. So here first is application, which market it is going, function, what is the function, whether it is blending, solid suspension, chemical reaction, or heat. So that thing we have to mention here, like aim of mixing, what is the aim, like why you are looking for a mixer. And then we need the characteristic of product. So like suppose it could be only one product, like you have only one thing, but heating is taking place, so in that it is one product. Sometimes it could be two or three, like you are mixing phosphate rock, water, and sulfuric acid to make phosphoric acid. So in this case, like you have to mention all the components you have inside the tank, and then you have to give the specific gravity, viscosity, at what is if it is solid particles, what is the size, and at what weight concentration you are mixing the different components. So that you have to mention here. And then while whether you want to use mixer while emptying and filling the tank, so that is also important, because it impacts the mechanical design of the mixer, whether any hazardous area, frequency, voltage available at site, the temperature and pressure, if you have anything. Yeah. And if you are using any existing mixer, you can mention here. If you are facing any problem with the existing mixer, that you can mention here. Actually, this is the tank details. So what kind of tank, whether it is a cylindrical tank or a rectangular tank, that can be mentioned here. What kind of mixer you are looking for. So mixers could be different type, like top entry, side entry, bottom entry with bottom bearing. So these things I'll explain in coming slides. So what is the tank geometry, like what is the top end and bottom end of the tank? So that we have asked the details here. And what is the like maximum liquid level, minimum liquid level inside the tank? Where is the outlet and inlet position? So those things. What kind of motor you need? So what efficiency, what voltage, what frequency, whether it is explosion proof motor is required or not, that has to be filled here. Motor, is it like a DOL start motor or VFD motor? So that you have to mention here. So If you need any kind of sealing, that has to be mentioned here. It could be either lip seal or hydraulic seal or mechanical seal or any kind of seal. What is the MOC you preferred for the wet end part, especially for the shaft and impeller? What is the MOC you are preferring? What is the painting? You need any painting? If yes, what category? And finishing, like if there is any polishing requirement of the wet end components. So those details will be needing for selecting the right mixer. So these are the actually details required so that we can offer you the right mixer for your application. And this is what we send to our customer to collect the details for selection of proper mixer. Yeah. So now we'll move to like what are the different type of mixers we have. And type of mixers, like it's not like, okay, these are the 3 types or these are the 4 types. Type of mixers can be defined based on different criteria. So like one of the criteria is what kind of flow the mixer is generating. That could be one of the criteria. How the mixer is fixed to the tank, that is another criteria. What kind of impellers we are using, that is another criteria. So different criteria. So here I have covered about axial and radial flow mixers. Yeah. So this is axial flow mixers. So in this case, it is called axial because the flow is parallel to the shaft. You can see the flow direction here in this. Yeah. So you see the flow direction here. The flow is coming out axially from the impeller, and it generates a down to up movement of the fluid inside the tank. So this is axial flow because the flow is parallel to the shaft and coming out axially from the impeller. So this will be like, if you see the impeller, this will be the kind of flow generated. And it could be like down and up, like how it is shown here, or up to down, like the reverse direction, whether it is blowing or sucking type of impeller. The flow direction can change, but it will be like this way. Axially, the flow direction will be axial. It will be making and forming loops. So what kind of application the axial mixer is used, it's mentioned here. So for solid suspension, like you want to suspend the solid particles. So in that case, you have to generate enough upward velocity so that the particles will remain suspended. So in that case, axial impeller will be used. Heat transfer, like if you have, like suppose you have heating coil at the bottom of the tank here, and then you want to make sure that the temperature of the slurry inside the tank is constant. In that case, the axial flow impeller will be used. And crystallization, like suppose the crystals has to be developed. In that case, this axial flow impellers has to be used. Then we have radial flow impeller. So in that case, the flow is generated perpendicular to the shaft, and it will come out radially from the impeller, like how it is shown here, like side to side. So if you zoom out at the impeller, this will be the flow direction. It is radially outward from the impeller and perpendicular to the shaft. So where it is used, it's used for emulsification. Like you want to mix oil with the water, so you have to break the oil, like you have to shear the oil particles or water particles to make it small enough so that it remains suspended and it becomes a solution. So for that kind of application, for gas dispersion, like you have a gas disperser at bottom of the impeller. In that case, again, you want to break the gas particles into smaller particles so that the contact area will increase, and the reaction, like for what purpose you are introducing the gas inside the tank, that will be served. And high shear mixing, so paint emulsification, gas dispersion, so that kind of application we use radial impellers. Yeah, so here we covered the type of impeller based on the flow pattern generated by the mixers. Here we are covering the type of mixers based on the mixer mounting. So here we can have top entry mixer. So it is mounted from the top of the tank. So the name top entry mixer. So here we have shown an example of top entry mixer used in coagulation application in wastewater treatment. It could be side entry mixer. So it's mounted on the side of the tank. So like this is the tank, this is the circumference, the diameter of the tank, and it's mounted at the side of the tank. That's why it is called side entry mixer. This is one of our mixer installed in crude oil storage tank application, what we have shown here. And it could be bottom entry mixer. So in this case, it's introduced from the bottom of the tank. So tank will be coming here. So like this part will be mounted onto the tank nozzle, and impeller will be inside the tank. And since it is introduced from the bottom of the tank, it is called as bottom entry mixer. And this is one of our mixer given for PVC reactor tank. Yeah, so these are the different type of mixers based on mounting, what we classify. Yeah. So now we come to the what are the mixer components? What will be the main components of the mixer? So in this image, we are showing like what will be the main components of the mixer. So these components has to be there. Like for the mechanical mixer, I'm saying these components has to be there. Maybe gearbox is like there could be a mixer without gearbox, like rotating at high speed based on the motor speed. So, but otherwise, like these components will be there for any mixer. Yeah, so we'll have a motor that will be like converting the electrical energy into mechanical energy and rotating the gearbox. Here we have the gearbox. So gearbox is required to achieve the required torque and the required output speed required for the mixer. Then we have a base plate. So base plate, we provide matching your tank nozzle dimension, or if it is mounting on a structure, that structure dimensions to mount it on top of your tank. We give this base flange. Then we'll have a coupling. So coupling, it could be different type of coupling. The purpose is to connect the agitator shaft to the gearbox shaft. So we have a coupling here. Then there will be mixer shaft, and then there will be impeller. So impeller, we call it as the heart of the mixer. This is what doing all the mixing operation. It is converting the electrical energy to the fluid, like to the hydraulic energy required for the process. So this is called as like this is the main part, the impeller for any mixer. So these are the main components. But other than that, there could be other components as well, like what we have shown here in the right. So for motor, like it could be different type of motor, vertical mounted, horizontal mounted, and in few cases the motor and gearbox could be connected through belt drive as well. So belt drive connection could be there, like what it is shown here. And then this is bevel. The gearbox can be bevel helical type also. So the motor will be flange mounted, that is shown here. And then in some application, we could have turret, what is shown here. It is also known as agitator stool. So this is required in case we need additional bearings, like suppose gearbox, like for big mixers, where the gearbox is not able to take all the axial and radial load like applied to the shaft because of mixing. So in that case, we may need additional bearing inside the turret. So this turret could come with additional bearing, like how it is shown here, the additional bearing. And in few cases where sealing is required, so sealing will also be coming inside the turret. So sealing, as I mentioned, it could be different types of sealing. It could be hydraulic seal, gland packing, mechanical seal, simple bearing seal. So turret, the purpose of turret is to house the bearing if bearing is required, or sealing if sealing is required, or for some maintenance purpose also we give turret. That is very helpful for ease of maintenance. Then we could have different couplings at the output. We could have different couplings between motor and gearbox, like it could be flexible coupling, pin and bush type, rigid coupling, IEC adapter. And at the output also, we could have different coupling, like we could have a rigid flange coupling or a sleeve coupling or a shrink disc. So different types of coupling can be there at the input side, like between motor and gearbox, and at the output side between the gearbox shaft and agitator shaft, different couplings could be there. And then the shafts will be there, and the impeller could be of different type, like some of the types are shown here. And the mixer could be supported from the bottom, or it could be suspended type. So here like we have shown this part, it is called as limiter ring or bottom bearing or bump post. So different kind of supports can be given at the shaft end. So the agitator could be like supported from the bottom or a suspended type. So supported type will be required when the shaft length is very long, and we don't want all the radial load and the bending load coming directly to the gearbox. So in that case, we give support at the bottom also. So what it does is it reduces the load acting onto the gearbox, plus it reduces the shaft of the agitator as well. So we could go for a smaller size if we give support at the bottom. So for that purpose, we are giving bottom support based on the dimensions of the shaft and the loads acting on the agitator. Yeah. So few things, like a lot of things are involved in selecting the right mixer. So here we are just covering two basic information that we do for selecting the mixer. Like for once we get all the process details and your requirement, like why the mixing is required. So first thing, like what we calculate is like what is the flow required for your application. Like suppose you give all the process parameters, then like suppose for solid suspension application, so there will be certain velocities will be required inside the tank to keep the particles in suspension, right? So we calculate those velocities, and for calculating those velocity, we need like what is the flow generated by the mixer. So to calculate the flow generated by the mixer, this is the equations that has to be used. All the manufacturers will use the same equation. This is the equation for calculating the flow generated by the mixer. So like QP is the pumping flow, depends on NQ. So NQ is a dimensionless number. It is a property of impeller. So based on type of impeller, this NQ, it's like power number and pumping number, flow number, we call it NQ. So this will be a property of impeller. NQ, N is the rotational speed, and D power 3. So this is the equation used for calculating the pumping flow. And once we know the pumping flow, we can calculate different velocities generated inside the tank. And from that, we can arrive like what is the, like whether that mixing is sufficient or not. So first we have to generate the, select like what is the flow required for the mixing application. And this is the equation used for calculating the flow generated by the mixer. Yeah. This is about the flow calculation, like how much flow is generated by the mixer. And then once we know the flow, we calculated the flow, then we have to calculate how much will be the power the mixer will be absorbing. So this is the formula used for hydraulic power calculation. So as you see here, so the formula is rho is the density of the slurry into NP is the power number. So for each impeller, it will have two dimensionless numbers, power number and flow number. So that is defined by the geometry of the impeller. Like so based on experiments we have to do at our lab, we will come to know like what is the power number and flow number of an impeller. Then speed cube and diameter power 5. So this is the formula used for calculating the hydraulic power. Yeah. And yeah, as I said, like this, it's not very easy to calculate the power number and flow number of impellers. So for that, we work with different third-party laboratories, and we create miniature models of our impellers, and then we do experiments and calculate like what is the right power number and flow number for a particular impeller. Plus, we do CFD analysis also. From there, we'll get to know what is the power number and flow number of an impeller. So at the bottom, this image, you can see like once we have these details, once we have these details, we can calculate the velocity generated by the mixer. So it could be flow velocity, upward velocity, and average velocity we have to calculate based on the flow, what we have calculated using this equation. Yeah, so for selecting the right mixer, so we need to decide three things only, like for defining the hydraulic parameters of the mixers. So first thing is type of impeller, what kind of impeller we have to use. So at Milton Roy Mixing, we have 40 plus impellers, different types. So we have to select the right mixer. So once that is done, the power number and flow number will be defined, like it will be fixed for that particular impeller. Then we have to select the impeller diameter and rotational speed. So once these three things are selected, we'll get the hydraulic performance of the mixer, like what will be the flow the mixer will be generated, what will be the velocity the mixer will be generated. So those kind of details we will get once we select these three parameters. Yeah. So once we select these things, like as I said, like once these things are selected, the impeller type, impeller diameter, and rotational speed, we can calculate the pumping flow and absorbed power of the mixer, and we can complete the hydraulic and mechanical design once we select these three parameters. And here, what we are empathizing is like not always what customers generally think is like if the power is more of a particular mixer, the performance will be better, but that's not always the case. So the flow has to be correct for the performance to be better, and power it varies based on the type of impeller, what diameter and speed we have selected. So not necessarily more power means the better mixer. The flow has to be calculated actually and compared whether the flow is enough or not, and not related to the power. Like not if flow is better, maybe the mixing will be better, but not like if power is better, the mixing will be better. That's not the case. Yeah. So here we have a very nice video to show like different levels of mixing. So based like once we calculate the mixing velocity inside the tank, then we can calculate like what's the level of mixing. So in this video, you will see like at different mixing level, like how the mixing will be looking inside the tank. So this is just video we have generated by experiments we have done in our lab. So I'll just play this video. Yeah, so just for this presentation, what I wanted to show is just a minute. We Yeah, so here you have seen like at different mixing intensity or mixing level, how the like it's a visual representation at different mixing intensity, how the mixing will look inside the tank. So here, like if you see like what we have shown here is like if you go from level 1 to level 10 of mixing, the power increases from 1 to 1000. So the level of mixing has increased by 10 times. Yeah. So the just yeah. So sorry. Yeah. So if you see here, like the level of mixing has increased by 10 times, but the power has increased by 1000 times. So if your process doesn't require that intense mixing, you don't have to go for higher level or higher flow or higher power of mixer. So we have to select the optimum mixing level, what is required. And based on that, we can reduce the power, and that reduces that helps in reducing the operating expenses. And the price also, like if you go from level 1 to level 10, the price increases by 5 times. So that's all like we have to select the right mixing level that is required. If we go for keep on like increasing the mixing, maybe it's not required for the process, but you have to pay for the operating expenses and high cost of the mixer. Yeah. So here, yeah. So here for this slide, we'll be explaining the importance of CFD for mixer selection and what we do for our customer when it comes to CFD. Yeah. So CFD, like we can do the analytical calculations, like as I explained, like what is the flow generated, what is the velocity generated inside the tank, what is the power required. Uh, but to uh, to validate the analytical calculations, we do CFD also for our customers. And for complex applications, it is better to do CFD because all the analytical based on the different complex tank geometry, it's not possible to calculate analytically alone, like what will be the dead zones, what will be the percentage of dead zones inside the tank. So for that, we do CFD analysis also, and it is very helpful in that kind of applications. This is the CFD we have done for a sulfur melter tank for a top entry mixer. So here you see like we based on that, like we can get the velocity contours inside the tank. So here we'll come to know like what is the velocity at different areas inside the tank and whether there are any dead zones or not. Like dead zones is like where the mixing is not adequate or the velocity is very low. We are calling as dead zone. So here, like in this application, there was a heating coil that melts the solid sulfur to liquid sulfur. So based on the velocity, we'll come to know where the velocity is less, and where the velocity is less, then heat transfer will not be proper. So this kind of analysis we can do through CFD. This is again one of the CFD we have done for side mixer. So for side mixer, generally it has to be mounted at 10-degree tilted angle, or it has to be swivel type. Then only the mixing will be better. So here we have shown like if you mount it at 0-degree, how the mixing will be, versus if you mount it at 10-degree tilt, how the mixing performance will be. So here you can see like here you see this is the velocity streamlines. So here you see like on the right side you see more red lines. So the velocity in that case is like more than wherever it is red, the velocity is more than 0.15 meter per second. And here when it is mounted at 0-degree, you see more of the green area. So the velocity is between maybe 0.03 to 0.1 meter per second wherever you see green and yellowish area. So this kind of test, like what is the best mounting position, also we can do through CFD analysis. And then we have a very an interesting analysis what we have done here. So this was a tank for wastewater treatment application. So customer was asking, actually based on the tank geometry, customer was asking for 3 mixers. But through CFD analysis, we have done and shown to the customer like 2 mixers give better performance compared to 3 mixers. So that helped in reducing the capital expenditure, because they have to buy only 2 mixers in place of 3, plus the operating expenses, because they have to pay like the power for only for 2 mixers and not 3, because the power we kept the same, only reduce one number of mixer. I'll just play this video. It's a animation, small animation. Oh, it's not visible. Okay, maybe I'll come out of a slideshow and present this. Yeah. So you see here 2 mixers. So these are the flow lines generated. So it goes through first mixer and it comes down, then goes to second mixer. This is the resident time. So more the resident time means better the performance is, like because the fluid is spending more time inside the tank and the mixing will be better. So you see here like the flow patterns, how it is generated. It goes through first mixer and second mixer, and then it goes to the outlet. But whereas if you come to the 3 mixer solution, like what customer was asking. So if you see here, there will be short circuit happening. I'll just play the video. So you see the flow patterns, like it's coming from the bottom and it's going out. So it's not going through all the mixers, because all the mixers are pushing the fluid at the bottom. So there is a short circuit happening. And in that case, resident time will reduce for few of the streamlines. And for those, the mixing will not be proper, because the fluid is not spending enough time inside the tank, and it's going without going through the mixers, and without the mixer is not the mixing efficiency is not good, and it's not mixing it properly. The mixer is not doing the operation properly, like that we can say. Yeah. So here is like what we do for pilot testing. So as I mentioned, like we do scale down model before doing the full mixer, before making the mixer for the actual tank. For few of the applications, we do scale down model, study in our lab, how is the mixer performance, what is the optimum flow required, what is the optimum power required, so that we do not give them more power to the customer, or like we give the optimum flow that is required. Like as I said, like if you increase the flow, the power increases a lot, and then the expenditure for the customer, the operating expenditure will be high. Yeah, so these are a few of the tanks we have done for a few of the pilot testing we have done in our lab. So some examples of that. This is for alumina precipitator. We made a 5-meter cube tank, and the actual tank was 5,000 meter cube. So we made the mixer small mixer. So for like if you want to scale down or scale up, there are different criterias. So we maintain those criterias. It could be mixing intensity, the tip speed, or specific power in few cases like phosphoric acid. So we maintain those criterias while scaling up or scaling down. so that we know when we scale up, the performance will be equivalent to what we are testing at our lab. This is an example for alumina application, precipitated tank, where we did a scale down model of 5 meter cube and actual tank was 5,000 meter cube. This is again scale down model we did in our lab for phosphate slurry application, where we made a scale down model of 50-liter tank and the actual tank was 500 meter cube. And this is again tank we did for iron ore slurry application, where we did a tank of 800 liters and the actual tank was 6353 meter cube for iron ore application. And for all those applications, when we are testing at our laboratory, we test with actual slurry. So we know what will be the exact performance of the mixer when it is installed at site. Yeah, so here for the mixers, like we have mentioned, like baffles will be there. If it is a cylindrical tank, we suggest customer to use baffles inside the tank. So what is the purpose of that? So we have an interesting video, so we have put it here. So like suppose if the tank is there, it's a cylindrical tank, circular cross section without baffles, how the flow will be generated. Okay. Yeah, so you saw from the video, like baffles, like it converts, like the agitation will be there, like the energy will be transferred to the fluid from the mixer, but the motion will not be desired, not what we need for proper mixing. So in this case, as you see, like it was just swirling, so it was rotating, but it was not effectively mixing. So we provide baffles, like no, we don't provide, but we ask customer to put baffles inside the tank, so that the motion will be converted into what we need, the desired motion, so that the mixing will be proper. So in this case, like suppose there was any solid particles, it will be settled, it will be like rotating, not settling, it will be rotating at the bottom of the tank and will not get a homogeneous solution. But we put baffles, like vertical plates around the tank wall, so it will break the vortex, like you have seen, like the vortex was forming here. It will break the vortex, give the required desired flow up to down motion, so that the mixing will be proper. So here are benefits, like what we mentioned here, without baffles and with baffles, what will be the benefits here? Yeah, so this again is a very interesting slide, and we tell our customer like they have to look beyond the purchase price. So most of the customers are like EPCs also, like if they're buying, they concentrate on the initial expenditure, the capex, what they have to do in buying the mixer. But we tell them that is not the right criteria, because if you see over the mixer life cycle, only 10%, 5 to 10% only will be the capital expenditure, and remaining 90 to 95% will be the operating expenditure. And that also, like majority will be the power expenditure, and only 2 to 3% will be the maintenance expenditure. So lowest purchase price, maybe it's beneficial at that point, but once the mixer goes into goes into production, and once you start the production, so if the power is like, it's like someone is giving like less expensive mixer, but it's consuming more power, then over the mixer life cycle, it's not a best solution, and it's not the cost effective solution what we are going for. So we have to look beyond the purchase price, and not only the capital expenditure. The major cost is hidden, and it is in the operating expenditure that has to be taken into account. So that is the slide. So lowest purchase price does not mean the lowest life cycle cost. So that has to be taken into mind for selecting the right mixer. So that's what like we also try to do is selecting the best mixer, like not to increase the more power, like what we want to give the optimum flow and optimum power. That's like the selection of the mixer is very critical, so that the initial capex will be low, and more important than capex, the opex will be low if the right mixer is selected and the operating power is low. And here we have shown different type of mixers what we have. So as I said, like we have 40 plus mixers. So we have mixer like axial flow mixers, the radial flow mixers. So what all different types we have are shown here, and many of them are patented design of Milton Roy Mixing. So we do a lot of R&D. We are very strong in R&D. So we keep on developing new mixer, new impellers by increasing the efficiency that gives the high flow, consuming low power. So we do a lot of experiments with third parties. We do a lot of CFDs, and we come up with new impellers that are very efficient and can give high flow with consuming less power. And these are our key markets. So as I said, like for the right selection of mixers, we need process knowledge as well. It's not only the knowledge of the mixer. So we have experts from different processes, different industries, and that is our key market. We try to be focused, very focused approach for few applications. So these are our key markets what we are targeting. So it is fertilizers. We have a lot of installations and different customers we have for fertilizer application. And for mining, so in mining we are doing for alumina application, for iron ore application, for cobalt, zinc application, we are giving our mixers. For hydrocarbons, we are mainly giving side entry mixers for ethanol blending, crude oil storage, bitumen application. So we give our side entry mixers for those applications. In petrochemical industries, also in O2C industry, we give our mixers for PVC application and other chemical industries. For wastewater treatment, we have a major presence. So we give mixers for the entire wastewater treatment cycle, starting like for neutralization, coagulation, flocculation, and pH adjuster tank. So different kind of wastewater treatment application we are giving our mixers. And general industries also, other than these industries also, few industries we provide our mixers. This is what Milton Roy Mixing, like what we have done in past, like the biggest power, biggest tank size, the highest pressure, what we are given our mixers for. So again, like this is not the limiting things. It's not like we can give maximum motor power of 1000 kilowatt only. We can go higher also, but this is what we have done in past. So if there is an application which needs high power, so we can give it. Not as I said, not a limiting parameters, but what maximum things what we have done in past. So maximum motor power we have given is 1 megawatt. So this is for a fertilizer application and installed in Jordan. Maximum tank pressure we have given is 180 bar mixers for tank with 180 bar pressure. The maximum tank size for crude oil storage in China we have given is 210,000 meter cube was the tank volume, and there were multiple side entry mixers installed on that tank. And maximum shaft length we have given is 47 meter, and it is in India for alumina application, precipitated tank. And this is what we do in house. So we we do the entire thing related to the mixers. So selecting with the right design. So as I said, like the selection is most critical, so that the mixer cost and the main important operating expense will be less. So we have to select the right flow and right power. So for that we do the selection, hydraulic and mechanical selection. For that we have our own, like we have built softwares for selecting the right mixers, and we do CFD and pilot testing, so that to know like the mixer selected, like we do analytical calculation, we have the selection softwares, but for few critical applications we do CFD and pilot testing as well. So we have laboratories and CFD experts to carry out these activities. We do machining of the components. We do like for the blades, like it will be like many blades are patented type. So we do forming, and these are manufactured in SP, special purpose machine. So this like these are like our own machines owned by Milton Roy. So there we do forming of the blade wherever the impeller is very special. Then we do in-house assembly of the mixers, and we have test setup where we do the testing of the mixers before dispatching to the customer. Yeah. So here, like we'll explain different type of mixers what we have. So I'll hand over to Rishab to carry on from here.
Okay, so thank you so much, Kuldeep, for giving the in and out information on the technical parameters, technical aspects of the mixers and different applications, different impellers, different key markets where we are providing our mixing solutions. So we would move on to the slide. So this is about our product portfolio, wherein we are offering top entry, HM, Helism, and floating mixers. Along with that, we have, these are basically for the wastewater applications. Then we have side entry mixers, basically for oil and gas, for crude oil applications. We have floating mixers right now. we are manufacturing. We have side entry mixers, two different kinds. We have belt type and we have gear driven. Then we have engineered to order mixers. These are known as Robin mixers. So having huge applications, huge shaft lengths, high power, but usually for alumina, mining, and mineral processing industries. So my major focus is basically on the Helicem HM mixers, side entry mixers for oil and gas used for wastewater industries. Basically, we'll talk about the HM and the Helicem top entry side entry mixers, top entry mixers for wastewater treatment, wherein we have the various applications into municipal water, drinking water, and wastewater treatment plant. We have for desalination plant applications, wherein we are supplying our mixers, providing better solutions using our HM and Helicem range of mixers. We have the application for coagulation, flocculation. Basically, for coagulation, we need a very high level of mixing. High agitation is required, wherein violent mixing, you can say, to have a better crossing flow. We are offering HM mixers and VRH mixers, wherein you have very less residence time to have a flash mixing kind of application. Then we have flocculation and denitrification process. So for flocculation, when we are after the coagulation process, so when we are when we are inputting the polymer into the tank, the waste will be the waste or the gong will be attracted towards the particular polymer or the flux, wherein the size of the flux will increase. Based on this, we have to provide a less or a mild agitation, so which is usually required in the flocculation process. So it will have a higher or a longer residence time for 10 to 30 minutes, and very slow or mild mixing is required. So in our Helicem range, we have FRH mixers, which are specifically designed for this application. We have side entry mixers. As you can see, we have the range. We have two types for belt driven and gear driven. You can see in the photograph in one installation. The kilowatt ratings we are offering from 7.5 to 55 kilowatt range with fixed type and swivel type. So the tank size could be around more than like 2 lakh meter cube, and we are providing a high efficiency 4-bladed hydrofoil impeller, which is a Saber, which is our patented design, and we are the operating temperature will be around 250 degree, and we are providing that with a shut-off device arrangement. So we are supplying for the side entry mixers. We are specifically supplying it for basically for crude oil, bitumen. Then we have crude oil blending, gasoline, and fuel oil blending. So usually these are the different applications wherein we are giving our mixing solutions to our customers. So we have Milton Roy Mixing Solutions in the metal and mining industry. This belongs to the engineer to order mixers or Robin mixers, wherein we are supplying it for phosphoric acid, alumina refining, iron ore, hydrometallurgical industry. So basically mineral processing and mining industries we are catering our mixers to. So it will have the first phosphoric acid manufacturing. You can see it's a high solids are there with 65% concentration with 1.65 as a density, and particle size around 2000 microns. So the power will go up to 1 megawatt, wherein our application will cater for solid suspension, homogenization, and heat transfer. So basically, this is what the critical application we have done. So we have supplied to IFCO, OCP, Madan, GFC, GIFCO, ICI, Polymex. So these are our key customers wherein we have served. For alumina refining, the same things goes for a higher solid density and higher solid percentage. We have up to 132 kilowatt power rating. with solid suspension, heat transfer, crystallization. So we have this particularly for the reaction in the for the digester reactor accordingly. So we have served few of our customers for Nalco, Hindalco, Madin, and Pioneer. So these are our key supplies where we have supplied our mixes. Next is for iron ore suspension. You can see the 70%, a huge amount of solids with a high solid density, 2.26 with 210 micron particle size, where power required is very huge, up to 250 kilowatt. So basically catering to solid suspension and homogenization. So critical components for the slurry pipelines will affect the pumps and pipelines. So we have served this for NMDS, AMNS, are a few of our key customers for this application. Now for the other mining industry, where we have the same thing, but here the power rating goes up to 350 kilowatt with the extraction of zinc, cobalt, nickel, copper, gold, and we have served our customers in Africa, China, and other European customers. So this is a wide range of applications wherein we have supplied our mixers, known as Robin mixers or ETO mixers. So this is for mixing solutions in oil and gas, water, and other industries. So polymers, which will have top entry, bottom entry. Bottom entry is one of the few cases we have done recently for one of our customer. Chemical, pharma, oil and gas, and major part is with water treatment, wherein we have up to 45 kilowatt as maximum. And the usual applications will be for flocculation, coagulation, and blending, dosing, flash mixing. So various applications in STP and ETP. So range of customers depends for different sectors from Reliance, GAIL, LG, DCW, SNF, IOCL, Aramco, HMEL, BPCL, Veolia, Aquatech. So around the different across different sectors, we have supplied our mixes ranging from top entry, side entry, bottom entry, and engineer to order mixes. So this is one of the supply we have done for slurry transfer, which is for phosphate rock transport. You can see the dia and the height. 16-meter dia and 18-meter height will be having a volume of around approximately 2,500 meter cube with high solid content of 65%. So we have supplied this particular MOC is in SDSS, and maximum kilowatt rating is 200 kilowatt. So the whole shaft, I think the tank is in, I think the shaft and this thing is in rubber lining with carbon steel. So solid particle size range from 200 to 1200 microns, and which are very, very abrasive. So depending on that, the MOC for impeller is chosen. So this is one of the supplies we have done in the past. So this is one more application for in the mining industry for coal slurry. The tank dimensions are huge with 24 by 26 and around 9,000 meter cube coal slurry with 60% of solid content, and we have 8 meter of impeller die with 2 stages. So very highly abrasive, and we have this particular installation in China. So we have this particular Robin range mixer for our alumina application. We had done that in the past 2 to 3 decades. We have supplied our mixers for like we have done 16 precipitator units with a maximum of 55 kilowatt in CS. So alumina production we have done. As you can see, there is a steady bearing at the bottom with 3-stage impellers for alumina production. This is the recent mixer we had supplied to one of our customer for bottom entry. This is a very customized mixer we have supplied from our Europe factory, basically for Reliance Industries, and the kilowatt rating was nearby around 630 kilowatt. So the process application would be for suspension of PVC beds, and which will ensure better heat transfer and thermal transfer. So as you can see in the photograph, there is a bevel kind of the particular motor gearbox, and along with that mechanical seal is there with a bottom entry impeller with the lantern stool and coupling arrangement. So this is our service network and our global reach over the globe. We have around 200 service engineers serving our customers along over 60 countries around the globe. So as you can see, the dot marks, we are helping our customers to provide them better solutions as a aftermarket service, and particularly we are serving them with if they face any kind of issues at site. So definitely that those dots will definitely help you out in any corner of the world. Then we have a Milton Roy Care program, wherein we have parts care for the planned and unplanned maintenance with price and lead time transparency. So all the inclusive solutions for the planned maintenance, any kind of training coupled with ease of ordering genuine spares. So we are providing from our service around the world with all the particular maintenance operations required, all the spares requirement, support requirement from Milton Roy, from all our global offices, including India. We are supporting our customers with that full zeal and enthusiasm. So this is about our manufacturing locations around the globe. First is from US in Ivy Land. Second is from Milton Roy Europe in PSP France. The third one is from Jengalpattu, Tamil Nadu, India. And fourth one is Shanghai, China. So we are serving our customers from these 4 units with the mixer productions around the globe, and supplying our mixers around the globe for sure. So why we need to choose Milton Roy Mixing? So based on our experience, we have 65 years of experience in all the different kind of process. We have very high efficient impeller design, state of art manufacturing facility, installations in India since 1984. We have which is very highly reliable and providing best manufacturing for the equipments. We have CFD capability and piloting capability here also. We are we are undertaking different pilot testing for our mixers with respect to scale up and testing our mixers. We have a good range of skilled application and engineering team serving our customers with all the quotations and drawing submissions. We have reliable subcontractors for vendors, like for motor, we have for coupling, gearboxes, and aftermarket. So definitely, these are some of our testimonials wherein we have from different customers. You can see from Indian Oil, then we have Aditya Birla, Hindalco, CPCL, then DCW. We have so these are our testimonials where we have customer has recognized and appreciated the performance of our mixers, and they are getting better solutions with optimized design. So that's what the proof of our mixing efficiency and technology in India. So these are some of our key customers where our customers have repeatedly trusted us with over the past few decades. We have served Hindalco, Utkal Alumina, Aditya Birla Group, Technip, Aquatech in water, ExxonMobil. So as you can see, there are a wide range of customers from oil and gas, water. Then you have you can see ADNOC, Dangote, Naira Energy from oil and gas, Aquatic in waters, Veolia, Ion Exchange in the water industry. There are n number. We have just given a brief list here, but definitely there are key customer. More of them are there, which we are not able to include in our slides. But these are some of our key customers. So thank you very much for this for attending the webinar, and I would then take up the session for open for questions, if any, and I and Kuldeep are available to take up a few questions. So I'll hand over to my colleague Balachandran to close off and to have this Q&A sessions. Thank you so much.
Thank you, Rishab, and thank you, Kuldeep. And let's have a Q&A sessions now.
Yeah, so we have some questions. So first question is like, hi, does the customer need to install buffers in a square tank type? Where can they install the buffers in the square tank? Yeah. So for this one, like as I explained, the buffers will be required for circular tanks where the cross section is a circle. The reason being, in that case, the swirling motion will be created. Yeah. So in that case, the swirling motion will be created. We want to avoid the swirling motion. So because in that, if the swirling motion is created, it is rotating. The fluid is rotating, but not effectively mixing. So in square tanks, because of the shape, the swirling motion will not be there. So in that case, buffers will not be required. It's required for cylindrical tanks only, and it has to be mounted onto the tank wall, maybe 3 or 4 in numbers based on our recommendations, and we give recommendations of the size also, what is the optimum size. So based on that, it has to be mounted on cylindrical tanks only and not on square tanks. Thank you.
What is the next one?
Yeah. So the next question is, what is the reason for my brand new agitator motor tripping due to load test after installation? Yeah. So for this one, like why the agitator is tripping, so there could be different reasons. So first thing I'll say is, like, as we know, like we have seen the formula for hydraulic power, it depends on the density of the fluid, the speed, and the diameter of the impeller. And again, the NP we call the type of impeller selected. So if it is tripping, so one of the reason could be the process parameter is not like the density. Like maybe for our calculation, we have taken a particular density, but at site the density could have increased due to some higher concentration of solid or due to any other reason. So if density increases, the power depends on the density of the slurry, and if the density increases, the absorbed power will be increasing and the motor may be tripping. That is one of the reason. Second reason could be the speed is not as per the calculated one. Like suppose we calculate the mixer has to rotate at 100 RPM, but due to some conditions like maybe frequency fluctuations at site, it is rotating at 105 RPM instead of 100 RPM. So the power is dependent on the speed power Q. So if it increases 105 to 100, the power increases a lot because it is directly proportional to power 3. That could be another reason, and maybe could be some other reasons. So like these are some reasons I explained, but we have to study the application, why it is tripping. So based on that, we'll be able to provide you solution. So these are few theoretical reasons why the motor could be tripping. The reason is absorbed power is higher and motor is not able to serve the absorbed power of the mixer. Yeah. So you can contact our after service team if you face any kind of issues with the motor tripping or any other operating issue with the agitator. So our team will be there for help you and give you proper root cause why the tripping is happening at site. Yeah. The next question is like, what are the sealing arrangements that MR can give for process applications? So that one, like we covered in one of our slide. So here, like different kind of sealing options, what we have is starting from simple seals like bearing seal or labyrinth seal, then up to very complex seals. Like we can give simple gland packing as well, hydraulic seal we can give. The hydraulic seal is it cannot contain any pressure, but it can contain all the vapors 100%. So the vapors inside the tank will not be escaping the tank. So for that, hydraulic seal can be given. And for pressurized tank, we can give single mechanical seal or even double mechanical seal if you want 100% sealing. It could be for pressurized tank, we can give double mechanical seal or single mechanical seal. So we have different kind of sealing options. So as per your requirement, we can provide the sealing option. Yeah, okay. Then next question we have is, for which application we use ship propeller type impeller?
So that is a marine propeller, which I think we are using. So that is basically for direct driven motor applications, where basically for direct driven motors, wherein the full 4-pole or 6-pole motor would run at a higher RPM without any kind of a gearbox. So that is basically usually for dosing applications, if it's in NaOH or some very smaller tanks. So wherein the shaft deflection would be much more than 10 to 12. So basically there we are using marine propellers.
So moving on to the next question we have, let us say we have FRP cylindrical tank and vapor provision is not possible. Then in that case, without vapor, how proper agitation is ensured? Okay, so for answer this one, like for cylindrical tank we recommend, but we understand for few application it is not possible to give the baffles as well. So for that, for the mixer, like instead of mounting at the center, we recommend to mount it bit eccentric from the center, like not exactly at the center of the tank. So it will be bit eccentric, maybe 10 to 12% of the tank diameter. In that case, also the vortex formation will be reduced. It will not be 100% eliminated, but the vortex formation will be reduced and mixing will be better. So in cases where baffle is not possible, the mounting of mixer has to be eccentric. Yeah. So the next question is, which brand of induction motor and gearbox can be used? Yeah. So
okay. So particularly for all the kind of mixers what we are supplying, we have the brands for motor like ABB, Crompton Breeze, Marathon, and we have Bharat Bijli, CGL. So these are the few reputed motor brands. And for gearbox, we have Bonfiglioli. Then we have Powerbuilt. We have ICBOA. So basically, these are the few brands which we are using.
And for bigger gearboxes, we have brands like SCW, Flender, Hansen, yes. Pro C gearbox for side entry mixer. So as we presented in our care slide, we are very careful in selecting our sub vendors as well. So they do have the people having experience and reach as wide as Milton Roy. So those kind of trusted brands only we are working for all the bought out components like motor, gearbox, mechanical seals, and other bought out components.
Proto gearbox.
Automotives.
It depends on the make requirement. If the customer asks for it, and we are much familiar working with Bonfiglioli and Powerbuilt. But if customer requirement is for automotive or any other brand, depending on the make list, we can go with that particular list also.
And for selecting a new brand like automotive, where we don't have experience, first we have to evaluate, go through your product, your experience with similar agitator application. So if it suits our stringent criteria for selecting the vendors, if it fits, maybe we'll be able to explore new vendors as well based on the experience and our criteria, if it fits in our criteria, selection criteria for selecting a new vendor.
So basically, right now we are getting good, performance through Bonfiglioli and Powerbuilt. We have faced very negligible complaints from these brands, these gearboxes, which are running very well at customer sites. And going with the new gearbox will take much more time to evaluate, as what Kuldeep already explained. So it depends on that particular aspect.
I have no questions from there. Okay. Thank you everyone for joining today's webinar. We hope you found these sessions informative and valuable. We appreciate your time and active participation. If you have any additional questions, please reach to us. A recording of today's webinar will be shared with all registered participants through email. Thanks once again for being with us. Have a wonderful day, and we're looking forward to connect with you again for future webinars. Thank you so much. Thank you, Kuldeep, and thank you, Rishab.
Thank you so much. Thank you so much. Thank you. Bye.